Good morning, everybody. Happy Monday morning, bright and early. Nice to see you guys in class. If you could give me a green check mark, and then I'll talk a little bit about what we're going to do today and on Wednesday. And then we'll spend some time going through an exam and any questions you guys might have. And then that's kind of what we'll be doing for the next few days. I think we have 3 or 4 classes left. And of course, we have no new material to cover, which is always nice to have that out of the way before the end of the year. A provincial review, Avery, will it be due by Friday? I'm in no rush, but I guess I need to get my grades in. So let's have everything that we've done so far, so all the unit learning guides and all the unit tests, everything like that, we'll make those all due by Friday. And then I'll make a review that you guys are going to be doing this week. I'll make that due on the Monday following the weekend, give you guys a bit more time. And if that's all right with everyone, I know it says grade cutoff is on Friday, so I don't mind if you guys need some extra time. You have your provincial's not this Friday, but the following Friday. So the only thing that's kind of puts a wrench into things a little bit is I have to have my grades in to the office. And so we can't just leave it forever until the day of the provincial, unfortunately, because my grades are due before then. So if that's all right, I'm going to talk about a few things I added to the course, and Ava will answer your question as well. So I'm just going to jump over to the course here. So last week, a few of us went to KSS and we did a motion lab. It was pretty interesting. I think I enjoyed it. It was nice to have you guys in there doing that sort of stuff. So that was Unit 9. There is a assignment here called Moving Man Activity. So if you weren't at KSS, there is a little assignment to do. It doesn't really take that long. And then if you were at KSS, if you want to submit your assignment in that same spot, I'll change the name of it a little bit later to reflect that. But for now, if you want to put it right in there, that would be fine. So Moving Man lab activity. Yeah, Abby, you handed yours in there, which is good. Abby, could I put in a couple questions? Yeah, we'll have lots of time to go through questions in the next few days. So let me just do my thing for a little bit, and then I will address any questions you guys have, because I'm sure I will answer them. I'll answer them in the course of what I'm doing. Taylor's stuck in no man's land. I don't know what to do for you, Taylor. She can't hear me. Maybe restart the computer? Okay. Well, that'll get you maybe where you need to be, Taylor. Thank you, Avery. Answering questions. You guys are all over it this morning. Okay, so what I was saying is last assignment for the year. Each unit we have an assignment. So this is the Moving Man. If you were at KSS, you've already done your assignment. And if you weren't, you can do this. It shouldn't really take that long. It has a little simulation you can do online. So have a go at that. The other thing I added this morning was final exam prep. Now I said I would add a few additional items to this, and I have. So you have 4 choices here. I'm not particularly, well, there's a few that are easier for me than others. So there is choice 1 year-end review, which is a really, really long booklet, which covers all of the learning outcomes of the course, has some examples and pictures and diagrams and things like that. So this is a really thorough review of the entire course. It will take longer, but it covers everything we've done this year. So that is choice 1. Below that, there's a chemistry review, which is optional. If you struggled with chemistry, it might be a good idea to look through this. I'll put, trying to think if I have an answer key for the chemistry review. I believe I do have a key for the chemistry review. The year-end review, if you choose to do that, I'm going to have to mark it by hand, and then I'll give it back to you. So you'll have an idea of what that looked like. Exam, or choice 2 and 3 are just old provincial exams. So if you want to do either one of those, what you can do is, I don't really even need you to print it off. What you can do is, you can simply just have a sheet of paper in front of you, write down the question number and answer. If you want to include work on there, I will, as I'm going through the test and marking your test, I can go through your work and say, hey, this is kind of where you made a mistake for this question, especially with things like chemistry, if you're doing like balancing or forming compounds, or something like physics where there's an actual calculation involved. If you show any work, I can look at your work and say, hey, this is how you made a mistake. So that's choice 2 and 3. Choice number 4 is the same thing, except it's an exam that's kind of like the ones you've been doing all along. It's built right into the course. This is a little bit easier for me because the course marks it for you. You get instant feedback in terms of the multiple choice. There's 47 questions of multiple choice, and then there's 17 questions written. So it's 80 marks. As practice exams, choice 2 and 3 are 80 marks as well. So that's choices 1, 2, 3, and 4. If you pick choice 1, 2, 3, you can just submit everything down at the bottom here. And if you do choice 4, the multiple choice will be marked for you, and then you're going to have to submit the written and submit it here as well. Can you do more than one? Yes. You can do more than one. I have no problems with that. Yeah, I will find time to mark them as well if you do more than one. And I would like it if you did these kind of closed book once you've prepared and studied and take it like it's an exam. I don't really need your parents to supervise you or anything like that. It's not kind of a huge deal, but you know, I would recommend that you would do all the studying you're going to do, make sure you know everything, and then go through it. And then if you have a few questions that you run into that you need to go look it up, look up an answer, you know, learn the material again, I don't remember this, or I haven't seen this before, and then go back and answer it, that's fine. The idea here is that this is an exam situation, kind of stuff that you're going to see, and I want you to just be prepared, essentially. So what I don't want you to do is sit down with all of your notes and sit down with all of the material in a computer and go through the test and just look up answers as you go. That's not the purpose of this. It's not going to really count for that much of your grade. So your grade's not going to be like drastically lowered if you don't do well on it. What I want you to do is make sure you're prepared and go through the test. Don't take 3 days to go through one of these tests and look up every question to make sure you know what you're doing. That's not the idea here. So those are your choices. This is due on Monday. I can put that in there. Maybe I'll put a little label up at the top here that says it's due Monday. So I would like it if you guys did this at the very end. So do everything you're going to do, prepare, study, and do this over the weekend upcoming, or you can do it during the week this week if you feel you're ready for the test. That's fine. So I think that's what I wanted to say about that stuff. I can print off of anything you guys want. I know the provincial exams are long. You know, they're like 50 pages, some of them. So if you want anything printed, just send me a message. I can have it waiting for you. If you just show up, I can find time to print it off for you for sure. You can do more than one. I'll mark them all. And maybe if you do like 2 or 3, I'll give you the best mark of them. How about that? I'm marking the I'll put the answer key for the Chem 1 up, and you can just go through it yourself. I'm fairly confident I have a key for that, so all the correct answers there. It doesn't matter, Abby, that's fine. The Chem 1 is just kind of an optional one to kind of support you. While I'm saying this, if there's anything else that you're kind of going through, you're like, wow, I really wish I had some more examples of questions like this, I can guarantee you I have, I can give you old tests that I have. I have like practice worksheets for everything. So if you're running into issues with something, you want to look at some additional questions specific to that thing, specific to our course. I know a lot of times you can go online and find a video of somebody doing Bohr models or things like that, but it might not be the way that I taught it, so you might be learning it a new way and you can run into problems and things like that. So if you need anything, if there's anything that's coming up that you're constantly getting wrong, you want to come in for help, we can arrange that. I think Wednesday this week we're going to have some time for you guys to come in. And if you need additional worksheets or you want to look at additional questions, I'll have them. So just send me a message and I can, send those out to you for sure. So that's kind of where we're at, where we're going. We have class today and we have class again on Wednesday. And then I believe we have class on Monday again. So I think those are our last sort of 3 classes. I'm pretty sure we have an open house on Wednesday this week. I'll send out a message to you guys and let you know when you can come in for extra help or things like that. And that's kind of that. You guys are asking about the practice exam that we did. Abby, I can for sure send you alpha, beta, gamma, fission, fusion stuff. Yep. That practice exam that Mrs. Ward gave you guys, that's the one we're going to kind of work our way through today and next day. So I'm going to go through it kind of question by question. I'll put up all the answers. Glad to see you here, Taylor. So we'll go through that exam coming up right now. That's all I want to say about the course, where we're going, what the next week's going to look like, week and a day. And I'm going to spend some time going through the exam that Mrs. Ward gave you. It was the practice exam. And then if you have any questions from anything else, I will go through that. Where did I put that practice exam? Right here. Provincial exam preparation. So just below Unit 10, it says practice provincial. This is the one I'm going to go through today and next day. If you were at the field trip, with Mrs. Ward, where you guys walked around downtown, you have a copy of that. If you want to come in and grab a copy, you can. If you want to print it off, it's there. If you just want to look at it online and just write your answers down, that's fine as well. So that's the one I'm going to go through today. And next day, I'm going to give you time to work, and then I will answer questions you might run into. And I'll put up all the answers. I will put up a key for you guys so you can look at that. And that's kind of what we're going to be going through. Before we get to that, I see, Taylor, you have questions about Unit 9. And if anybody else has anything from Unit 9 Learning Guide or anything relating to Science 10, I would be happy to go through that. And then once I get all of your questions out of the way, I'm going to start looking at that practice exam, give you guys some time to work on it, and then I will answer any questions you have about the exam. But for now, let's jump over to Unit 9. All right, the last page 1, Unit 9. I know I forgot to mention this. On question 10, page 6, I was going through the question in class, and I kind of paused, and I thought, okay, this is one of those teacher moments where you're like, why don't I know how to do this? The problem I was running into was I was trying to figure out a way to use an equation to find the displacement from this velocity time graph. And I said, oh guys, I'm going to have to get back to you on that one. And the reason I was running into problems with it is because I couldn't think of a way to do it with the equations you have in grade 10. And I went back to my office and I sat down and I started to look at it. I'm like, well, there is no way you can do this with grade 10 equations. So that's kind of why I was so confused in the middle of class. So the fact that it's asking you to use an equation to find the displacement given a velocity time graph isn't a grade 10 topic. So I left you with a couple important notes here. The first thing was you can't use velocity as displacement over time if an object's accelerating. And then I also said, hey, you guys can find the slope, and that would be really good as well. So you can't do 10 on the second to last page. And that's an important thing that I kind of realized once I left you guys. So the second part of the question, use the equation. You can't do it, but you can use the area. It's the area of a triangle. You guys know how to do that. So I don't want to go any further into that. Taylor, I'll get to your questions. I see Anna, you have a question about the last page. Last page 1, unit 9. So all these little graphs. We'll definitely talk about that. Would the area kind of question be on a provincial? I highly doubt it, Avery. Yeah, I don't think I've ever encountered anything like that. So there's always a chance that they could ask a question like that, but I don't think I would worry about it. I'd say there's very, very low chance they'd ask a question like that. And then Abby wants atoms and ions. So I'll start up at the top with Taylor's questions, and then I'll work my way down. Page 2, number 7, unit 9. Where are you? Page 2, number 7. Okay, at the bottom of a hill, toboggan moving 12 meters per second forward accelerates at negative 0.5 for 10 seconds. What is the toboggan's velocity at the end of the 10 seconds? Show the equation on all the steps. Okay. All right, what do we have here? We have a toboggan moving forward at 12. So I know that is my initial velocity because that's how fast it's going. I have a negative acceleration, so that means it's slowing down. I have a time. And it says, what is the velocity at the end? So I'm trying to find the final velocity. This is one of those two-step type problems where you need to first use the acceleration and the time to find the change in velocity. And then once you've done that, you can use the fact that you know the change in velocity, you know the initial velocity to find the final velocity. So 2 steps. The first thing I need to do is find the change in velocity. So I can go, I think my formula sheet's here. I'm trying to find change in velocity, which is the acceleration times the time. So if I look on my equations of motion, delta V is A times T. So let's go back knowing that. So change in velocity is acceleration multiplied by the time. Okie dokie. Delta V is A. In this case, my acceleration is negative 0.5 meters per second squared. I'm accelerating that long for 10 seconds. So my change in velocity is going to be negative 5 meters per second. Now, I know a change in velocity is going to be a final velocity minus the initial velocity. In this case, I'm looking to just find the final velocity. So what I'm going to do is I'm going to go back to my formula sheet, and you can always solve for these on your own, but we have a formula sheet, so we might as well use it. The final velocity is the initial velocity plus the change. So this is the formula I'm going to use. I'm trying to find the final. I know the initial, and I know my change. So final is the initial plus the change. V final is the initial plus my change in velocity. My initial velocity was positive 12. My change was negative 5. So my final velocity is going to be 12 minus 5, which is 7 meters per second. And because it's positive, I know it's going forward. So in these physics types questions, the most complicated ones you're going to get are the ones where objects are accelerating and you end up with 2 steps to the problem. One, you have to find the change in velocity, and then once you've done that, you can use the change in velocity formula to find the initial or the final, or it just depends on what it's asking. So I could see why we would get confused on questions like that. Page 3, number 15. If a car is going 100 kilometers an hour, passes a bystander, then passes another bystander, 20 seconds later is going 120, what's the car's average acceleration? So acceleration is a change in velocity divided by time. I know that my car was going 100, so that's my initial velocity, and then it's going 120, so that's my final velocity. This is my time, 20 seconds. The tricky bit about this question is your velocity is in kilometers per hour and your time's in seconds. So you can't just plug them into the formula and solve. You need to convert one or the other into either seconds into hours, or you need to convert kilometers per hour into meters per second. It doesn't matter which way you do it. One thing I will tell you though is if you're given a question like this, look at what your answers are given in. If you see a bunch of answers on a provincial exam, A, B, C, and D, and it says, I'm just guessing here, but it says 2 meters per second squared, 7 meters per second squared, negative 2 meters per second squared, and negative 22 meters per second squared. If that's what the answers look like, then convert everything to meters and seconds. Don't convert everything to hours, find the answer, and then sit there and scratch your head like, oh, well, this is in hours, but the answers are in meters and seconds. What did I do wrong? Well, in this particular question, you're going to have to look at what the answers are and then choose to convert to get answers that make sense. Now, it doesn't ask, it's not specific as to what the acceleration units you're trying to find are. So we can find acceleration in kilometers per hour squared. It's going to be a really small number. We're probably not going to, actually it won't be that small. You're not likely to see the units very often, but converting 20 seconds into hours is a pretty straightforward process. So 20 seconds, I want to get rid of seconds, and I know that I can have 1 minute is 60 seconds, and then I want to get rid of minutes. So I put it on the bottom, and I put hours on the top. 1 hour is 60 minutes. All right, so we're going to go 20 divided by 60 divided by 60. So we get 0.0055 hours. So a very, very short amount of hours because 20 seconds isn't that long compared to an hour. My change in velocity is going to be my final, so 120 kilometers an hour minus my initial, which was 100. And then I'm going to divide by my time, which is 0.0055. So BEDMAS says I have to do my subtraction first. 20 kilometers per hour divided by 0.005. And I don't know what that's going to be. So I'm going to have to use my calculator. 20 divided by 0.00555. So that's 3,600 kilometers per hour squared, which is a really weird unit to measure acceleration in. Doesn't really make a lot of sense. I have a feeling the answer is probably in meters per second squared, but that would be fine as an answer because it doesn't ask specifically which units we should use. All right, Anna, you asked about the last one on the Unit 9 learning guide, which I assume is this chart with all of these different things in it. And is there anything specifically that was tricky? I know a bunch of you have submitted this already, and generally speaking, the answers to them were pretty good. Where the answers kind of were a bit, not wrong, but just off, were this guy here and this guy here. The ones with a distance time graph, but the line was kind of curved. So what you need to do is just describe the motion. So you need to look at what type of graph you have first and then describe what the object's doing. So for the first one here, you have this line. Let's say it doesn't matter what the number is, -2 or something. And you have an object that's, as time goes on, 1 second, 2 seconds, 3 seconds, 4 seconds, the object's just sitting at -2 meters. So you need to describe what's going on. Object is not moving to the left of another object. So it's just sitting there. Let's go down to this curved line. And it's negative. Everything's below the x-axis or the time axis. All right. When we first talked about this, we said, okay, the slope of a position time graph is the velocity. So if I took the slope right there, I took the slope right there, and I took the slope right there. The slope right here looks like that, then it looks like that, and then it looks like that. So the slope is getting steeper, which means the object is speeding up, which means it's accelerating. And because it's all below the x-axis, in the negative direction. So that means the object's just speeding up, going backwards. Whereas, if I looked at the other one that I said a few of you had some issues with, if we look at the slope here, it's pretty steep, and then the slope here is less steep, and then the slope here is almost horizontal. It is, in fact, horizontal. So this means the object is going really fast, and then it's slowed down to a stop. So object starts very fast, and then slows to a stop. Now, there are many ways to describe them. So whatever you put in there, I just kind of use my judgment to figure out if it was kind of accurate or not. Just because you didn't describe it exactly as I did, that's fine. So yeah, that's all you do, Anna. Generally speaking, I think you guys did really well. We didn't ever talk about acceleration time graphs. It's there if you want to figure out what it's doing. Given the knowledge that you have, you should be able to figure it out. But if you don't, if you want to just skip it, that's fine as well. So that's kind of that. Did anybody have any further questions about that one in particular? I would do more if you needed. Avery answered that. Atoms and ions. Okay, Anna, we're good? Perfect. Abby, just reading your question. Atoms, don't have a charge, ions do. So if you have an atom, it's neutral. That means the number of protons equals the number of electrons. And in an ion, the number of protons does not equal the number of electrons. So you have either more protons or more electrons. So that's kind of the difference between those two. Alcohols are hydrocarbons that have an oxygen in there. So like CH4 is methane. And then if we had CH3OH, that's methanol. So we did talk a little bit about it, some of the alcohols. You should just know that an alcohol is a hydrocarbon with an oxygen in it. If you have a hydrocarbon with an oxygen in it, it becomes an alcohol. So we had CH4, we had C2H6. So if we had H5OH, I don't think that's ethanol. I could be close. I always get confused because there's a double bond in there. So if you have this O in there, it becomes an alcohol. So that's methanol, ethanol. That's kind of the hydrocarbons with oxygen become alcohols. You should just be able to identify if it's an alcohol. If it has the oxygen molecule kind of bonded in there, then it's an alcohol. Oh, so they're asking about ones that we didn't talk about. Sorry. Avery, I put the objects accelerating negatively backwards. Is that right? It's kind of like a double negative. It's like, don't not do that. What, does that mean to do it? Yeah, it's true, Avery. The statement is true, but it's just kind of a different way of saying something. Don't not do that. Just a double negative. Just means do it. So yes, technically it's right. There's an easier way to describe it, I guess. So yeah, there's nothing wrong with that. A couple more on the last page, for sure. Yeah. Maybe let's look at a velocity time one, and then we will see if there's a tricky one. Let's maybe do the very last one here at the bottom. You have a velocity time graph. So the first thing is important to understand what type of graph you're dealing with. I don't have numbers, but I can imagine this is whatever, -5, and then I can have, +5 up here and 0. So if the velocity time graph crosses an x-axis, the time axis, the horizontal line, that means the object stopped. So this means it's moving backwards. It's slowing down though. 5, 4, 3, 2, 1. It stopped. Now it's moving forward. 1, 2, 3, 4, 5. So I could write something like initially moving backwards has positive acceleration because the slope is positive, moving up to the right. And then I could write something like ends moving forward. If you remember that the slope of a velocity time graph is acceleration, you could describe the motion pretty easily because you could just say, well, it has positive acceleration. It's slowing down in the negative direction, then it's moving forward. There's lots of different ways you could describe it. You guys did a good job, the ones that submitted it on the one above here, this distance time with the position doesn't change, and then it moves and then stops again. That's good. I don't know what, maybe let's look at this guy here. We have a velocity time graph and our line is just a horizontal line. Now on a position time graph, this would be an object not moving. But because this is a velocity time graph, let's say this -2 As time goes on, the velocity is unchanged. So constant negative velocity. Or you could write uniform motion in a negative direction. You could express that lots of different ways as long as you kind of got the gist of it. That's all I was looking for. One more random question. Polyatomics like CN, if there are 3 molecules of CN, would I put brackets around like CN3 or would I leave the brackets out because CN doesn't have any subscripts? I think I've understood what you're saying. So CN cyanide, let's say we have sodium cyanide. No, let's not pick sodium. Let's pick something like, I have a periodic table here. I have to take shots in the dark here. Let's go calcium cyanide. Now, calcium is Ca with a charge of +2. Cyanide is Cn with a charge of -1. I think. So if I want to combine these two things together, I can think about crisscrossing my charges. I can think about these things balancing out. But I'm going to end up with Ca, Cn. If I just put a 2 here, I think this is what your question's asking, Abby. Is that what I really mean? Well, not really, because I didn't. Now, by just putting a 2 without brackets, you've changed the ratio of Cn. There should be 1 C for every N. If I just throw a 2 out back, that means now there's 2 N's for 1 C. And I've changed the ratio of those elements, so that doesn't work out. So I don't ever want to not put brackets around a polyatomic. So I always put brackets around polyatomics because the ratio of elements in a polyatomic are set. That group of elements, in this case just carbon and nitrogen, they hang out together in a 1-to-1 ratio. They always have 1 carbon for 1 nitrogen. That group has a charge of -1. And that rule is true for every polyatomic you deal with. If you have more than one of your polyatomic, you must put it in brackets. It makes, to kind of preserve the ratio of elements in those polyatomics. Okie dokie. Where are we at? Lots of questions today, which is great. So, Abby, are we good with the alcohol thing? And I haven't looked at that chem review in a while, so I think I'm not sure. And the ions, maybe I can load it real quick. Just take a second. Okay, this is just the sole chemistry review. Abby, you mentioned something about atoms and ions kind of being interchanged. Lewis structure. So I don't have, unfortunately, the ability to write on this, but kind of in this section here, it talks about atoms and ions, the difference between those. It's specific about atoms. Okay, perfect. That's good. Let's maybe find the alcohols thing that you were talking about so everybody has a little bit of frame of reference to what we were discussing. I think this is probably where you were looking at that, Abby. I'll just take a little snip of this and then I can throw it in here. There we go. All right, so this is where the alcohols come up in that chemistry review. C2H4, C2H6, C3H8, so that's methane, ethane. Then we get propane, and then methylpropyl butane. So 1 carbon is methane, 1 carbon here is ethane, or methanol. 2 carbons is ethane, 2 carbons is ethanol. 3 carbons is propane. This is going to be propanol, NOL. And then butane is butanol. So the naming for hydrocarbons, methane, ethane, propane, butane, and then the naming for alcohols is the same, except you change the ending to "-al". So methane, methanol, ethane, ethanol, propane, propanol, butane, butanol. That's how the naming works for those guys. Another important thing is the exceptions to the rule. These guys contain carbon but are not organic. Okay. For the purposes of I guess I shouldn't have erased that, but for the purposes of the provincial exam, you should probably know the first two for sure, methane and ethane, methanol, ethanol. If you knew the third hydrocarbon, methane, ethane, propane, you'd be even better off. These ones are methane almost always comes up on exams, CH4. It's just one of the common ones. It's like water, H2O. You just need to know what methane is. Ethane's a little trickier, not quite as common. Usually if they put ethane in a question, they will tell you what it is. But CH4 is extremely common molecule. It is just like water. You should just know what CH4 is. It's called methane. Methanol, ethanol, not quite as common. They'll probably label those ones for you. No, completely unnecessary to memorize the first 10. That is Chemistry 11 topics, so you'll be way ahead for next year, Abby, which is great. So if you knew the first three, you'd be way ahead of the game. Methane, ethane, propane, methanol, ethanol, propanol. What would be useful to know is they're flammable, and that's basically it. That'll get you a long ways on the exam. All right, that took longer than I thought, but that's okay. I'm glad you guys had so many questions. What I wanted to do now was look at this exam. So again, this exam is right from the course. It's not what I wanted. And it is in the sort of practice section. So not in the exam prep, but right here, provincial exam preparation. And it says practice provincial. So if you didn't get it on the field trip with Mrs. Ward, it's here. This is what I'm going to go over today and next day as well. So instead of me going through question by question, which would be extremely boring for you guys, what I would like is maybe we'll take some sections of the test, and as a way to kind of force you guys to do it, I'll give you guys some time to look through it and answer the questions. And then we'll come back and we'll meet, and I'll put the answers up. And if you run into questions after you know the answer, like, hey, I guess B, or I thought it was B, why did you get C, Mr. Borden? Then I can, discuss it further. Or if you get to a question where you just don't know. Now, one really important thing, and I've said this before about reviewing for these types of exams, is it's important for you to acknowledge the things that you don't know. Don't go through these exams and spend a lot of time going through the stuff you know, because that feels good. You're getting the questions right. Everything's great. You need to spend time on the stuff you don't know. If that means going back and watching a video, asking me a question in class, that's how you're going to get better prepared for the exam. And that's how you're going to kind of do your best on the exam, is doing the stuff you don't know, or the things you have questions about, or even on these exams, there's usually about 5 questions which are really hard. And there's no way to avoid them. They're just there. And if you want to think about it this way, it's kind of going to separate the people who get 100% on the exam for the people who get 95% on the exam. And there's a big difference between getting 100% on this exam and getting 90% on it, or 95. Again, with provincial exams, when they create the exam, they're not trying to trick you. They're not trying to, get you to get a bunch of questions wrong. They just want to know that you know the material. That's the point of it. So don't think that, the creators of the exam or myself were out to get you by doing this exam. It's just there. We want to know that you know the material. Now, even if you know just a little bit of the material, you can do fine on these exams. They're not hard. There's lots of really, really basic, easy questions that will get you through the exam. There are some really hard questions that are going to separate the hundreds from the 95s, but for the majority of students, like when I was your age, I didn't have a Science 10, but I was like a C plus B kind of student. I probably would have just done fine on an exam like this. There's enough questions that are really basic, really straightforward that you could get a pass on the exam very easily. So don't get all worked up about it. I'd say the Science 10 exam is probably an easier exam than the Math 10 exam. You can know less going into the science exam and do better than you could in math. So keep that in mind. How much will it affect our marks? So all provincial exams are 20% of your grade. So again, the magic number is 62.5%. So if you go into an exam with 63%, all you need to do is show up to the exam, write your name on the test, and you pass with 50%. 62.5% is the magic number for any provincially examinable course. As long as you get 62.5% going into the exam, you've already passed the course. So there you go. 20% provincial, 80% class mark. All right. I've been through a few of these questions already with you guys, and I would like to go through some more. And I guess the point here is that I'm really good at Science 10, and I've done these exams a bunch of times. So by me doing more questions, you aren't going to get any further ahead. What I would like you guys to do is, we have until 11:20 or so today. So what I'm going to do is, we're going to put up a timer of maybe, let's go 10:30. Yeah, let's go 40 minutes. And if you go through the test, I don't care how you do it. Go through it, answer all the questions you know, and then, go back and start addressing the questions you don't know, look it up, see how you can do. But I want you to just spend 40 minutes going through this exam to kind of see what you know, see what you don't know. When we come back after 40 minutes, I'm going to start circling questions, circling answers. And if you got something wrong and you want me to do it or spend time on it, I'd be happy to do that. Or if you're going through the test and you find a question that's really tricky, instead of saying, hey, Mr. Borden, can you show me how to do question 22? I've already showed you how to do it. That was the point of the whole course. So what you need to do is go back, look it up, see if you can find something that relates to it in the course. And then after you've done that, if you've took the initiative to try to find the right answer and you can't, then you want to ask me, I'd be happy to go through it. But by me showing you how to do questions again and again and again isn't going to help you learn how to do those questions any better. So it's kind of on you guys now. You're totally going to get out of this what you put into it. If you just sit here and just take it in and watch me do questions and watch me circle answers, and you're like, oh, I thought it was A, but he said B, but B kind of makes sense, you're not going to get a lot out of this. It's important that you're kind of active in this process. For a lot of you, you have nothing to worry about with this exam, so it's just a matter of how well you can do. If you're with me this far, you're all going to get 50% for sure. I can guarantee that nobody is going to get less than 50%. It's just a matter of how good you can do on this exam. That's kind of where we're at. So unless anybody has any questions about what I've just said, what we'll do is we'll put up a timer of 40 minutes, get up, walk around, take a little break, come back, look at the exam, start writing down answers, start looking at questions you don't know how to do, and then I'm going to just, after 40 minutes, I'll start going through the answers, and if you have questions about it, I'd be happy to go through that. So that's where we're at, 40 minutes, and we'll see you guys back here at about 10:30.